I think this is the worst way of solving a quadratic equation, and I hope nobody really does this. Let's have a look. Here we have 6x squared plus 5x minus 11 is equal to 0. What we will do is, let's use the rational zero theorem. So, what I mean by that is the following. Let me give you guys the possible rational zeros of this equation here. First, we are going to go to the constant term, which we have negative 11. And then we have to ask ourselves, what are the factors of negative 11? Which is just 1 and 11. But we will have to consider both the positive and also the negative version of them. So these are the 4 things that we have to try. But not yet. We will also have to consider we will also have to consider the leading coefficient, which is a 6 over there, and divide the factors of 6, which we have 1 times 6, and then 2 times 3, and then of course the plus or minus of them. So what are we really checking though? Here we have 1 divided by 1, so it's 1, and then positive, negative. And if you do 1 divided by 6, that's going to be 1 over 6 plus or minus. 1 divided by the 2, and then 1 divided by the 3. And then let's do 11 divided by that, so plus or minus 11. This divided by that, so it's plus or minus 11 over 6. Oh, everybody's here, oh my goodness. And then plus or minus 11 over 3. So 1, 2, 3, 4, 5, 6, 7, 8, and then plus or minus. We have a total of 16 possible zeros, right? Rational zeros. But the worst thing is that when you have a quadratic equation, you might not even have a rational zero in the first place. But anyways though, what we are going to do is we're just going to make our selection and hope for the best. So I'm going to just start with, let's say 1. So if I plug in 1, we get 6 times 1 squared plus 5 times 1 minus 11. Do we get 0? 6 plus 5 is 11 minus 11. Hey, that is equal to 0 because I set out the equation to be this way. Anyways, now, what does this mean though? So note that we know an answer x is equal to 1 is a 0, which is going to imply if you subtract 1 to both sides, x minus 1 is a factor of this polynomial. So that means I can factor this to get some x minus 1 times the other part. And that's still equal to 0. But what's the other part though? For this, let's do synthetic division. So here we go. I'm going to write down the coefficients from the equation here. So we have 6, 5, and negative 11. And because we know 1 is a 0, we are going to put down this 1 right here. If you're looking at the factor, when you have x minus 1, you are going to put down positive 1 right here. And then to do this, you just bring down the 6, and then you do 1 times 6, which is 6, put it here. And then you are going to add them up for synthetic division. So that's 11. Continue. And then right here, you will get 0. The remainder is 0. That means 1 is actually a 0. So that's a nice connection. And this factor is going to be 6. X plus 11. This power went down by 1 because we have x squared in the first place and then divided by x to the first power. So it's just like that. So now we have successfully factored the quadratic. So now all we have to do is just write x minus 1 is equal to 0, which means x is equal to 1. And then also do the other one. So 6x plus 11 is equal to 0. So that means 6x is equal to negative 11. And then divide the 6 to both sides. X is equal to negative 11 over 6. So second answer. There are better ways to solve a quadratic equation than this. I just thought about it on the other day because I have been teaching pre-calc, and one of the topics is that we solve a polynomial equation where we have degree 3 or higher. In those situations, it's much harder to factor. And we might have to rely on the rational zero theorem, meaning you should have guess an answer first and then use that to give you a factor, and then you keep breaking down. But I was just thinking about what if we did that to a quadratic. Don't do it.